Hi, my name is Santos Tobias, and this is Team 5's Band in a Box project proposal.
Today, I, Aaron Seagal, Shondell Wright, and Joseph Woodrell will be discussing with you our project's problem description, requirements, constraints, and design criteria. We will then each describe our instruments and conclude our presentation with a summary and citations. Problem description. Each instrument must demonstrate multiple tones and be able to collaboratively play maroon and gold fours on hit wonder, Ode to Joy.
And now on to Aaron with our project's requirements and constraints.
Thank you, Santos. Aaron Siegel here. I will be talking about requirements and constraints for the Band in the Box project. All instruments must fit in a 2 foot by 2 foot by 2 foot box. They must produce tones to play high, medium, and low voices of Ode to Joy. A $15 maximum budget is allotted to each team member. Tax and shipping is not included, and any recycled material must be cost estimated. And now on to Joseph for criteria and the decision matrix.
Thank you, Aaron. This is Joseph Woodrell to discuss the criteria and decision making that we used. Our primary criteria were size, cost effectiveness, as being aesthetically pleasing, being able to generate multiple tones, and the overall craftsmanship required to build the individual instruments. Our decision matrix laid out our weightings that we chose for all three designs, and while the design that we ended up choosing, design 1, was not the most aesthetically pleasing, it was the best as far as size and cost effectiveness in our assessments, so that is the one we ended up choosing to go with.
Thank you. In conclusion, we have seen that each instrument that's been modeled is able to play the selected tones that are in the song Ode to Joy that the band will be playing. Each instrument has been modeled and designed to be able to fit in the 2 by 2 by 2 box. Each instrument has also been designed in such a way that it will come in under the $15 budget that the band has put on. Here's a list of references that we have used to be able to find conversion factors and come up with the rest of the information that we need. Thank you.
Team 5 decided for their wind instrument a bamboo windpipe.
Played upright like a clarinet, but with no mouthpiece so it supports being played like a flute, the instrument is designed to stand straight up in the band's box, which supports our size constraints, and will have fingering holes to vary the pitch for all the required frequencies. The bamboo windpipe will also be designed with strings to give it kind of a native appeal, all of which can be budgeted for a whopping $7.05. As you can see, the length of my instrument will vary based on the mid-range tones required to play Maroon and Gold 4's song Ode to Joy. I have a max length of 32.8 centimeters, which is approximately 1-3 inches, to achieve a full octave with the required notes.
And now on to Aaron with our first percussion instrument.
My instrument is the high-range percussion instrument. As you can see in my sketch, it is 6 copper pipes attached to one end of a square MDF board. A square MDF board will be 8 inches by 8 inches and be 3/4 of an inch thick. It will easily fit into the bottom of the box as required. And to make this instrument, I will use MATLAB with the given equations and variables, and that will help me calculate a table, and the table will hold the frequencies along with the lengths that have been calculated. And lastly, as you can see in my budget, not many materials are used, and I easily fall under the $15 budget constraint.
For my design, I chose to do a fauna fiddle style instrument, which is essentially a single-stringed instrument. The primary strength of the instrument will come from a square steel tube, which will be used as the backbone to resist the strength of the string being tensioned. There will be a small RC servo on the very end of the metal bar, which is going to change the tension of the string, which is how I will vary the tone of the instrument as it's being played. The main wooden body will be constructed out of balsa wood because it's easy to work with and relatively inexpensive to obtain. And then it will be automated with a microcontroller, TI MSP 430. My sketch of the instrument can be seen here, and here's my equations of how I figured out my proper tension that I'm going to need for the string. I selected a PL024, which is just an off-the-shelf lower range guitar string with a 0.024 inch diameter to allow me to obtain the notes required for my low voice section of Ode to Joy. and the tension range is within the string's capabilities, so that should allow me to tune everything in like I want to. This shows I'm pushing the limit on being able to stay under $15, and that may require me to drop down from using a bow and just going to a plucking arrangement, because that would save me probably at least 30% of my budget. Thank you.
Thank you, Aaron. For this design project, I was tasked with coming up with a mid-range percussion instrument. Now, in the song Ode to Joy, it has 11 different notes that need to be played, hence the 11 different bars that you can be seen here. Now, since it's going to be a traditional xylophone style, each bar is going to be anchored using a wooden dowel. When it's all said and done and the band is finished, the whole thing will break down and fit into the box. The percussion instrument that I've designed is going to be 8 inches in length, 6 inches in height. Each bar will be 3/8 inches in width and height, with varying lengths to hit the different notes that need to be played. As you can see, we'll have it traditional xylophone style, largest on one side, smallest on the other. And you'll be able to use your mallet that you can see here. Now, to model all this, I used MATLAB. So I started playing with different sizes. I found that 3/8 was going to be the cheapest, so that's what I went with. Right here is the equation that I have in MATLAB to be able to model everything. This chart shows the different notes associated with the different frequencies, which are then associated with the different lengths that would be needed. Cost. Totaling $14.83, which comes in under the $15 constraint limit per instrument that the band has set.